This video explains the example for calculation of the dead load. A steel universal beam 410/60 which has a span of 6 meters is simply supported. It carries the slab which is 2400 millimeters wide and 150 millimeters thick reinforced concrete slab along its length. So it's supported along the length, so it's carry this slab. Determining the dead load that the beam is required to support and show the answer on a line diagram. So basically this is a steel beam and the steel beam is carrying this reinforced concrete slab. Now to calculate the dead load, we can calculate the weight of the slabs that carried by these steel beams, and also the weight. So the steel beam need to carry their own weight, so we need to calculate the self weight of the steel beam. So let's talk about the self weight of the reinforced concrete slab. Now for the reinforced concrete slab, as you know, we can have a density of the reinforced concrete slab, so that density will create this kind of pressures, and we are interested in the UDL load that applied onto the steel beam along its length. So we are first going to have this density which is in the rate, and then we are going to convert into UDL load. So now weight of the reinforced concrete slab, which can be calculated by using the equation density kilonewton per meter cube times the area meter square. Now this area is a perpendicular area, right? So this area is so if we are interested in finding this UDL load, we are basically looking for this perpendicular area, right? Okay, we don't get confused between this area and this area. Look, this area is or this length or this area is parallel to the UDL load that we want to calculate, right? So we can't take this area, we need to take this area which is perpendicular to this one. Now if the question is asking to find the loading along the width of the steel beam, or for example if you want to calculate this UDL in this direction, then in this case we take this area. But our question is to find along the length. As you can read on the questions that we need to find the UDL along the length, so we need to multiply this area. So 25 kilonewton per meter cube. If I can show you where this density coming from, if you are checking the AS NZS 1170.1 2002 on page number 19 on table A1, somewhere here concrete unreinforced concrete is 24 kilonewton per meter, but if you have a reinforcement you need to add 0.6, so 24.6. here we take the round 25 kilonewton per meter cube, but you can take 24.6 kilonewton per meter cube or 25 kilonewton per meter cube times the area, which is this thickness 150 millimeter, which is 0.15 meters, times this width, which is 2.4 meters, so that will give us the answer 9 kilonewton per meter. So that's the UDL load due to the weight of slab. Right, now the steel beam has to carry their own weight. Now this steel beam's universal beam is 410 UB60. Now how do we find the UDL loads? For this case we need to use the one steel table. Now in the one steel tables is a catalog that we use in Australia for selecting the universal beam. Now for the universal beam, you can see I can zoom. So here universal beam we have 410 UB 59.7, that is the equivalent to 410/50. Now this 410 is the one that is this D. So that tell us what is the depth of this universal beam. The UB stand for universal beam, and 59.7. Now this is important here. 59.7 is the weight of the steel beam. So if you're taking 1 meter steel beam, it weighed 59.7 kilogram per meter. So this is the value we're going to take it, 59.7 kg per meter. Now that is coming here, 59.7 kg per meter, that is coming from one steel table. Now it's in the kg per meter, and now we calculated as we calculated kilonewton per meter, we need the answer in kilonewton per meter, so we need to convert kg per meter into kilonewton per meter. So first of all, let's convert kg into newton by multiplying gravity 9.81, so that become newton per meter. that's multiplication give 585.6 Newton per meters, and we need the kilonewton, so it's dividing by 1000, that will give us 0.59 kilonewton per meters. So once we calculate the two weight in kilonewton per meters, we can find the final dead load G equal to weight of the steel beams is 0.59, and the weight of the slab is 9 kilonewton per meter, which is final answer would be 9.59 kilonewton per meters. Now question also asking to draw the line diagram. So if I draw the line diagram, for examples, if I draw this beam which is 6000 millimeters, so if I draw this beam along this one, so if I looking from this end, I can draw this beam like this beam here, which is 6000 millimeters, and this UDL load, that UDL load I am drawing it here, which is 9.59, and is simply supported, so pin and the roller. So that is the case of simply supported. Then this is the steel beam, and this is the UDL load applied. So that is the line diagram. That is the final answers for these questions. Thank you very much.